I did test this. Okay, there we go. All right, a little bit about Esri, just some numbers here. The key thing about us is that we're a GIS, Geographic Information System software company, and we're the global leader in GIS. And GIS is based on location, intelligence, so knowing where you are. And we base it on the science of where. So we've heard this a lot. Geospatially, I don't need to rehash that with this community. Of course, we need to know where the data is, where we're observing, so that we can understand things around us. Some numbers here you'll see in terms of where we're at, 33,000 businesses across the world, 12,000 national governments across the world, 30,000 city and state, or so like local governments across the world. And then of course, nonprofits. So you're gonna see throughout this presentation, and I know that they make these presentations available, so you'll have access to all of these resources, but I have 1 million QR codes. I have one marketer, that's what she does on a daily basis, is create all of these. No, I'm kidding. But you can access the one over here on the left, gives you more about our company. This one I draw your attention to because if you see across the bottom here, conservation, climate change, education, science, disaster response, and sustainability, those are key pillars of Esri. We're not just a software company. We care about these. And this QR code shows you GIS for good across those markets, so you can gain more insight in how we're working with organizations all across the world. So if we think about our software, it's really about geospatial infrastructure. So it's a whole ecosystem. It unites data, people, analysis, all around the science of where. So location intelligence is very important. Digital twins, thinking from the depths of the ocean all the way to the tops of the clouds. So we can have those slices of information to give us an insight into our environment so that we can create solutions that make our planet more sustainable. And that's at the core of our technology. Our technology, our software is driven by our users. They give us our requirements. They're our beacon of what we do next in our software. We invest 33% of our revenue back into research and improving our software to serve our users. So we are civil servants in a way to our users. And this whole ecosystem allows us to be able to collaborate, users to collaborate with others across boundaries, borders, for a common goal of working on solutions for a sustainable planet. Visualization, we've heard a lot about visualizations. If we think about climate and weather data, net CDF, multi-dimensional data, very difficult to view, but being able to visualize that in 3 dimensions is important. And we work with all different users and data format types, working with standards. We have a whole group that work on standard boards to ensure that we can ingest all forms of data types for use for visualization and analysis. And we have the ability to be able to view these net CDF and multidimensional data in whatever dimension you need to make sense of what you're seeing. This is just an animated example with all of our tech. You can create dashboards. This one is just about sea level rise, and it's just showing at different points in time how you can look at an area that's inundated by water. And this is just analysis in the background that is allowing you to do this. So you can think of for flooding type events, you can do this very quickly. With all of our tech, everything is integrated. A lot of our users will use this, even in a story map. It's a way to communicate information to everybody. You can have the data behind it, can be embedded, and be able to show these either dashboards or analysis for folks to be able to understand a little about maybe the risk associated with sea level rise, for example. This kind of visualization is very powerful in, say, in a venue like this, whether it's a community hall, if you're educating users on the importance of flooding and how to see this information and make sure that you're being resilient and paying attention to it. Change detection on the right, let's see, my right side, more graphical analysis, scientific analysis, ways to be able to visualize data. With respect to forecasts, we have a lot of products and services available. Many of our users produce things and then we can store those as APIs. Many APIs can be shared out. You don't have to have our software to be able to utilize everything. And they make that information available. There's a few examples here. This QR code will allow you to go and check out any one of those examples. For weather services and apps, like I said before, APIs, we develop a lot of APIs. So whether you're a scripter, I heard somebody talk about Python. We have a large developer community that utilize our tech to create end products. And we have a very large presence on GitHub with over 200, I think it's up to 260 projects available. Even within our software, you can use Model Builder. It's just a way to put together a workflow, and you can export it out to a Python script and put it in a notebook. And we have a whole library of notebooks for others to use. And we have people can have access to those and still not, in some cases, some of the tools that they use within the notebooks, you would need a license to our software to be able to utilize it, but not every tool. A lot of our geoprocessing tools can be outputted to a Python or R script, and they're interchangeable, and you can use those without even having the software. We do a lot of collaboration with our hub technology. So think of it as an ecosystem. It's just not a tool set. And it's a way to bring data, people, and initiatives together. This one, I've got 3 coming up. They're examples with our hub technology. The first 2 are by National Weather Services. So this one is by NOAA, and they're using hub technology to alert the public about 5 perils. So inland flooding, coastal flooding, drought, extreme heat, and wildfires. And the goal of this platform is, it's just a web-based technology, a web interface. Anybody can access it. There's a QR code. Anybody here can access it. It won't really be really relevant for you because it's really just in the US, but you'll get the concept. And the goal of it is where you are standing in the US, I can look and see my risk assessment associated with those 5 perils. And this was a product of NOAA scientists. It's their algorithms and mathematical models, along with data from many agencies. So this is an example of many agencies coming together. We have within our software platform a living atlas of the world. So it's a full database of data. And we have all our national agencies' data within our software. So we're able to stand up this kind of infrastructure very quickly to allow users to then, they could then disseminate this information out to the public in ways that the public can understand. So please do check this example out, and it will show you, are we going? There we go. They even have a steps to climate resiliency to help end users to start to look at risk associated with those 5 perils and the next steps. With this kind of portal, they also have linked it to funding in the US to be able to go and access funding to be able to do the research to make their communities more resilient. The other thing with this hub technology is that it provided a feedback loop so that the end users, the public, the first year when they released this, which was a couple years ago, the public had an input and were able to say, hey, I want this or I want that. And it was also a way to download data. With this hub technology, you can make it as secure as you need and as open as necessary. So what they discovered that when they put this hub out, most of the folks were actually downloading data. They weren't expecting that because they figured they figured they had all the answers that the end users might come to such a portal for. But it ended up being maybe a data dissemination portal. And then over the years, they've tweaked it to improve it to really respond to what the end user wants. So that's just an example of hub technology. Here's another hub technology with UK Met. We work with them very closely. And they built a couple years ago their local authority climate service. And this is version 2 of it. The first year was also a way to disseminate data to their end users. And the second iteration, you'll see off to the side, that's a QR code, a link to a blog post that we co-produced with them and our Esri UK office, where they're now, the next phase of the UK Met's climate portal was to actually disseminate reports in addition to data. So they also had a feedback loop in using this ArcGIS infrastructure, and the end users wanted reports. So they now have those available. So it's just a way to work at a national level, get data out to the end users, as well as some analysis-ready information and products that might be useful to them, and then get their feedback. The third one is in Africa. And this was also another collaboration example, an African Geo portal. Perfect, thank you. And that portal is being run totally by several countries in Africa, and they were building a digital twin, getting their data together. Now, it may not cover the entire country, but you have to, or all of the continent, but you have to start somewhere, and it is a way to start to aggregate data as well as being able to disseminate it and have that feedback loop and put forth what you want the public to have. And you can have different gates in terms of, for research, we talked about research data, you can have an avenue for that. You can also have an avenue for commercial companies. There's all different ways that you can configure such a system. With communication, I mentioned earlier a bit about story maps. This is an example for WMO. I've used a story map to actually talk about global climate in 2020. Story map is just a way to communicate information. You can have data in there, you can have a viewer in there. I have another link in here about a story map about sea level rise. I showed you that example earlier. Well, it actually, within the story map, it has the viewer in there. So you can go in and play with that viewer yourself just to get a sense of how it works. And with story maps, we have many users. NOAA actually uses as one of its main form of communication and education, because it's a way to increase awareness and educate folks on complex topics and making it so that everybody understands. So this is that story map I talked about earlier. You'll see up across the top, it has many different topics or going through the story, and it's just an online web-based way to view information, and embedded in there is a viewer that helps you to play and see how sea level rise is going to happen in this particular area. So you can do that kind of thing with the ArcGIS ecosystem. I've got a couple minutes, so I'm trying to. Some additional resources when we were talking about capacity building. These are some examples, some checklists. We heard yesterday WMO has a checklist. I showed you earlier for climate resilience, NASA has a whole plan that they go through. You can download all of that information. This one up here is on climate crisis. That's also information for you, tested best practices of what people are doing in that space, so that you can learn, benefit from what's already taking place. An applied meteorology webinar series, there's 5 parts of it, freely available for anybody here, and it shows how GIS technology is used in those 5 different areas of applied meteorology that you could have access to. I highlight the next one, you'll see it is on early warning system, so warnings, so real time, how we're using our tech to actually read real-time data and issue warnings via cell phone. So that will just give you an example to show you the art of the possible. The other thing that we have is the Esri Disaster Relief Program. This is a 30-year program it's 30 years old this year. My manager actually has been running it. And you see request GIS assistance. Anybody in the world that's experiencing a disaster can request that, and it is complimentary. You do not have to have our software. You don't buy our software. It is in an emergency. We are there to help. And you'll see these are for wildfires, severe weather, flooding, earthquakes, and the like. All of these, we have best case scenarios, how to work with it. We have training on how to do it. And it comes with a whole set of resources to help out those in need. And in many cases, we actually send staff to support. And that's a way of giving back. And we're very, very serious about that, this whole initiative. The next one is on best practices. Here, there's a bunch of links. And then finally, over the 30 years, we have worked with 11,000 organizations in all of these different categories to help in disaster. And this is all complimentary. And like I said, we've gotten better at being able to help from so many years' experiences. So you can see a little summary here. We don't do it all on our own, of course. We work with many, especially our users. They're the ones who drive the advancements in our technology to improve. And we have partners, DTN, one of our partners who is actually here, work with them. We work with many because then it's an extension. We know that our planet needs a lot of help, and we believe everybody has a place and space to help, and we will work with everybody. Think of us as Lego blocks. We meet everybody where they are. This is my contact information up top, and then Carlson is here as well, my colleague. He is the one who would oversee solutions. And, you know, we're a pretty big company, but we have a lot of resources and a lot of different ways to help. There's no one size fits all. We do all kinds of ways of helping, and we're happy to talk with you over the little bit of time that we have left. I know we've talked to a lot already, but if there's any way that we can help, we really want to. So please reach out. Thank you. I don't know if we have any questions. Good.